Alright, this is ChemQuest 40 colligative properties. So first we're going to start with dissociation and total molality of particles. So we have NaCl that'll break down to Na plus and Cl minus. So the molecule will break up, but covalent molecules, however, it will not break up. Alright, so we have this question, we want to find how many moles of calcium ions and how many moles of nitrate ions there are. So there's 1 mole of calcium and 2 moles of nitrate. So if you add these together, it's 1 plus 2, so you get 3 total moles. So we have a concentration of 7.5, and there's 1 mole of Ca2 plus and 2 moles of NO3. So it's 2 times 2.5, because there's 2 moles of NO3 plus the 2.5s for Ca2 plus. That equals 7.5. So we have a concentration of 3 mgCl2, and we want to find the total molality of all particles. So it's 3 for Mg2 plus, and since it's mgCl2, it's 2 times 3, which gives you 6. You add them together, you get 9. So the molality is first solved by getting the number of moles, so it's 45.7 divided by 106. It gives you 0.43 moles. And then the molality is solved for by 0.431 divided by the weight of the water, which is 0.2 kilograms, so you get a molality of 2.16. So remember, this is sugar, and sugar is a covalent, so it will not break up, so the molality will stay at 3.5. So this is the equations we need for boiling point and freezing point. Now, it's freezing point, it's Mt times the constant for boiling point, and then for freezing point, it's Mt times the constant for freezing point. So those are 0.515 and 1.853 respectively. So the first thing we want to do is, for this problem, is to solve for... So the first thing we need to solve for is the Mt, so that would be 2.5 times 2, because there's 2 parts to NaCl. Then we plug it into the equation, so it would be 5.0 times the constant of 1.853, which gives you 9.3 degrees Celsius. So it will be, since it's the freezing point, it's 0 minus that number, so the final temperature is negative 9.3 degrees Celsius. Now we're going to find the boiling point of calcium chloride. So once again, we multiply the molarity times the number of particles, which is 3, so you get 11.1. Then we plug it into the equation again with the constant for boiling point, so you get a temperature of 5.72 degrees Celsius. And since it's boiling point, you add 100 to it, so you have a final boiling point of 105 degrees, 0.72 degrees Celsius. Alright, so we want to find the freezing point for sugar, but sugar doesn't dissolve, sugar is covalent, so it will not dissociate. So it's just the concentration times the constant for freezing point, so you get 4.17 degrees Celsius. You subtract that from 0, so you get negative 4.1 degrees Celsius. So the next thing is we're going to do is Raoult's law, which is P of solution equals X of solvent times the P of solvent. So for vapor pressure, we're going to solve for the moles of solution first, which is 21.5 divided by 42.44, which gives you 0.507 moles of solution. The same thing, we do the same thing for water, which gives you 4.68 moles of water. Then we're going to plug it into the equation. X solvent equals moles of water divided by moles of water plus moles of solution, which gives you 0.902. Then we plug it into the equation from this previous slide, 0.902 times 2.3, because that is the pressure of the water at 20 degrees Celsius, and you get 2.08 kPa. Alright, that's that.